Welcome to the Detecto Olympics. I have my medals. And yes, I do use the word detecto a lot. It's fun to say. My name is Jason Richards, Microsoft technical trainer and data detective. Yes, Detecto Olympics isn't a real thing, but it's a great way to grasp the concept we'll cover. We're going to investigate a data design pattern called the medallion architecture, which helps you organize data in a lakehouse logically and improve its quality as it moves through different layers. This pattern can make your data more reliable, consistent, and easy to analyze for various downstream tasks. We'll look at clues covering what a medallion architecture is, how to implement it, how to secure it, and how to achieve continuous deployment of the architecture. Join me as we dive into the case of the mysterious medallion, where we'll transform raw data into gold. Ready to crack the case? Let's go. Data lakehouses in Fabric are built on the Delta Lake format, which natively supports ACID, atomicity, consistency, isolation, and durability types of transactions. Within this framework, the medallion architecture is a recommended data design pattern used to organize data in a lakehouse logically. It aims to improve data quality as it moves through different layers. The architecture typically has three layers: bronze, or raw, silver, which means validated, and gold, or enriched, each representing higher data quality levels. Some people call it a multi-hop architecture, meaning that data can move between layers as needed. This architecture ensures that data is reliable and consistent as it goes through various checks and changes. It also guarantees that the data is safely stored in a way that makes it easier and faster to analyze. The medallion architecture complements other data organization methods rather than replacing them. You can think of the medallion architecture as a framework for data cleaning rather than a data architecture or model. It ensures compatibility and flexibility for businesses to adopt its benefits alongside existing data models, allowing you to customize data solutions and preserve expertise while remaining adaptable in the ever-changing data landscape. So that's an overarching look at the medallion framework. But what about these layers? The bronze or raw layer of the medallion architecture is the first layer of the lakehouse. It's the landing zone for all data, whether it's structured, semi-structured, or unstructured. The data is stored in its original format, and no changes are made to it. The silver or validated layer is the second layer of the lakehouse. It's where you'll validate and refine your data. Typical activities in the silver layer include combining and merging data and enforcing data validation rules like removing nulls and deduplicating. The silver layer can be thought of as a central repository across an entire organization or a team, where data is stored in a consistent format and can be easily accessed by multiple teams. In the silver layer, you're cleaning your data enough so that everything is in one place and ready to be refined and modeled in the gold layer. The gold or enriched layer is the third layer of the lakehouse. In the gold layer, data undergoes further refinement to align with specific business and analytics needs. This could involve aggregating data to particular granularity, such as daily or hourly, or enriching it with external information. Once the data reaches the gold stage, it becomes ready for use by downstream teams, including analytics, data science, or machine learning operations. Depending on your organization's specific use case, you may have a need for more layers. For example, you might have an additional raw layer for landing data in a specific format before it's transformed into the silver layer. Or you might have a platinum layer for data that's been further refined and enriched for a specific use case. Regardless of the names and numbers of layers, the medallion framework is flexible and can be tailored to meet your organization's particular requirements. Think of it, you could have titanium, vibranium, adamantium, the nth metal, all these different layers. All right, that's overkill, but you get the point. Onwards. Moving data across medallion layers refines, organizes, and prepares it for downstream data activities. And there's more than one way to move data between layers, ensuring that you can choose the method that works for your team. Here are a few things to consider when deciding how to move and transform data across, and understanding the difference between data transformation and data orchestration helps you select the right tools for the job within Fabric. Data transformation involves altering the structure or content of data to meet specific requirements. Tools for data transformation in Fabric includes Data Flows Generation 2 and notebooks, kind of like the athletes participating in the Detect Olympics, on the front lines doing the work. Data orchestration refers to the coordination and management of multiple data-related processes, ensuring they work together to achieve a desired outcome. The primary tool for data orchestration in Fabric is pipelines. And these would be like the coaches for the athletes, orchestrating activities to accomplish goals. Now that you have a solid understanding of the medallion framework, let's investigate the clues for how to put it into action within Fabric. I mean, after all, we're still detectives. First step, create your Fabric Lakehouse, obviously. You can use the same lakehouse for multiple medallion frameworks, or alternatively, you can use different lakehouses and even different lakehouses in different workspaces, depending on your use case. We'll dive more into this in a bit. Next, design your framework layout, define your layers, and determine how data will flow between them. The most straightforward implementation is to use the bronze as the raw layer, silver as the curated layer, and gold as the presentation layer. Then we need to determine how we will move the data through our layers, like how you'll ingest data into your bronze layer using either pipelines, data flows, or notebooks, and how you'll transform data into your silver layer. You can do this using data flows or notebooks. Transformations at the silver level should be focused on data quality and consistency, not necessarily on data modeling. The gold layer is where you'll model your data for reporting using a dimensional model. Here you'll establish relationships, define measures, and incorporate any other elements essential for effective reporting. You can have multiple gold layers for different audiences or domains. For example, you might have multiple gold layers by use case or by department. Here we'll go with use case. We also need to implement how you'll enable downstream consumption of your data. You can do this using workspace or item permissions, or by connecting to the SQL Analytics endpoint. Here we're going to connect this folder to an Azure Machine Learning Workspace data store to perform machine learning on it. And here we're creating enriched files that can be easily landed into a data warehouse solution. Something else to consider is availability. We may be relying on several processes that can fail at any time and should have redundancies in place for those types of situations. During ingestion and transformation operations, enable checkpoint storage locations to ensure that if a failure occurs, we can prevent substantial data loss. Now that your medallion framework is in place, data teams and the businesses can start using it to query and report on data. Fabric has several tools and technologies that enable you to query and report on data in your lakehouse, including the SQL Analytics endpoints and direct lake mode in Power BI semantic models if it's in premium capacity. The SQL Analytics endpoint in Fabric enables you to write queries, manage the semantic model, and query data using the new visual query experience. The SQL Analytics endpoint operates in read-only mode over Lakehouse Delta tables. To modify data in your Lakehouse, you can use data flows, notebooks, or pipelines. You can also use the SQL Analytics endpoint to connect to your Lakehouse from third-party tools and applications. In addition to using the SQL Analytics endpoint for data exploration, you can also create a Power BI semantic model in direct lake mode to query your data in your Lakehouse. When a Power BI report displays a data element, it fetches it from the underlying semantic model, which in turn accesses the Lakehouse for data retrieval. To enhance efficiency, the default semantic model preloads frequently requested data into the cache and updates it as necessary. This approach is called direct lake mode and truly gives you the best of both worlds, the performance of a semantic model and the freshness of Lakehouse data. So building the medallion framework, check. Using the data from our medallion framework, check. Next, we'll share a couple of considerations to keep in mind when managing your lakehouse, including how to secure your lakehouse and how to handle continuous integration and continuous delivery, otherwise known as CI/CD. You can secure your lakehouse by ensuring that only authorized users can access data. In Fabric, you can do this by setting permissions at the workspace or the item level. Workspace permissions control access to all items within a workspace, whereas item level permissions control access to specific items within a workspace and could be used when you're collaborating with colleagues who aren't in the same workspace, or they only need access to a single specific item. You can strategically store different layers of your lakehouse in separate workspaces for improved security and efficient capacity management. This approach not only enhances security, but also optimizes cost effectiveness. Also, access is an important security consideration. You should define who needs access at each layer, ensuring only authorized personnel can interact with sensitive data. Some examples are provided here on suggested access at each layer. Sharing of Fabric content should be discussed with your organization's security team to ensure that it aligns with your organization's security policies. Defining a continuous integration and continuous deployment process for a lakehouse architecture involves several considerations to ensure a smooth and efficient deployment process. Some considerations are listed here. While some of these are related to processes and practices, others are related to the tools and technologies used to implement CI/CD. Fabric natively provides several tools and technologies to support CI/CD processes. Git integration in Microsoft Fabric enables you to integrate development processes, tools, and best practices straight into the Fabric platform. Fabric's Git integration enables data teams to back up and version work, revert to previous stages as needed, collaborate with others, or work alone using Git branches, and leverage the capabilities of familiar source control tools to manage Fabric items. CI/CD is crucial at the gold layer of a lakehouse because it ensures that high quality, validated, and reliable data is available for consumption. Automated processes enable continuous integration of new data, data transformations, and updates, reducing manual errors and providing consistent and up-to-date insights to downstream users and applications. That enhances data accuracy, accelerates decision-making, and supports data-driven initiatives effectively. Way to earn those medals. Now it's time to roll up our sleeves and hop back into the Detectolab 5000 to put knowledge into practice.
Here we are in our environment, and we're going to be talking about the medallion architecture. So let's get this set up in our system, in our lake house here. First, we were going to navigate to the lake house. So I got my workspaces. Let's get into the workspace. We have our lake house down here. We'll go into our lake house. And the plan is that we're going to add this into our files. Now, there's a couple ways that you can approach this, and you can approach it however you want. There's no wrong way to do it. Well, there's probably several wrong ways to do it, but there's a few right ways. There's a few ways that you can do it besides doing it this way. Is that you could do it in the actual storage account associated with this. Maybe set up the folders in your OneLake Explorer. But here we're going to do it through our files so that everybody that's in the environment and has access to this lake house can see the different folders. Now, in order for us to create our processes, first we need to create the folder paths, right? So that's what we're going to do first. In our files, we're going to add a new subfolder, and we're going to call one bronze. And then we're going to call another one silver. And I'm not going to create a gold one, and there's a reason for this. The reason I'm not going to create a gold in the files here is because typically the gold standard is going to land, or it sometimes is going to land in the actual service that the data is going to be used for. Now, yeah, you could create another file folder here for gold, but we're providing a simple example in this demo. So I'm just going to add a table to the actual lake house itself, and that will be my gold. Now, again, there's different ways that we can do this, but from here, you know, I would be reporting it from the actual lake house. So you could apply your gold to a folder level, or you could apply your gold to the individual, you know, the tables itself. I can't create subfolders in my table, so I can't create a gold table standard here. So I'm just going to apply this into my gold standard or my gold folder level of the medallion framework into the actual tables itself. So how are we going to do this? I like automation. So if I go back into my workspace, I'll show you that I do have a pipeline that I've created that's going to set this stuff up for us. And fortunately, I already have the folder paths. Once I've created the folder paths, these are identified by these folder paths. So I'm just going to execute the pipeline and then show you what's in here. Now, this is a two-stage pipeline. We have a copy data stage, and we have a notebook stage. So I'm going to execute this, and then I'm going to show you what's happening and just reinforce the concepts as we're doing this. So obviously, I could schedule this pipeline, right? So if I wanted to automate this process, maybe do it on a daily or a weekly type of scenario where we're constantly searching for the files in our in whatever system is producing the raw data, and then moving the raw data into our bronze folder, then we can do that. Or we can just manually run it, which is what I'm going to do now. So I'm going to run this notebook, and you can see that it's queued up. And then once it starts, it'll show down here that it's queued up, and it'll start processing it. But let's look at the steps in here, and I'll show you kind of what's going on with this. So in the actual copy tab, I have my source and destination. These are going to be the main points to consider here. Is I need a source and a destination. This is going to land in our bronze. So this is just the raw data. So I'm essentially connecting to some sample data in a storage account. That's what this symbol right here represents, is a storage account. And I'm calling on a specific file path. In this case, we're pulling in a New York City taxi data set. It's yellow cab and green crab information from New York City cab service with different columns representing fares and distances and things like that. Where is it going? Well, we're just ingesting the raw data. So I've identified the bronze path as the file path for this. So what's going to happen is it's going to pull all the sample data in. If there was updated sample data in there, it would upload that, and then it would overwrite any existing folders or files that are in this bronze level. Sometimes you might not want to do that. Sometimes you might want to set up a process where it's writing new files, and you can do that within here, but this is just a simple demo. And that's the copy data phase. So the notebook phase, you can see that there's a notebook, and I have to get into it to actually show you what it's doing, but I'll show you the settings. I have a notebook called New York City Taxi Clean. So in order, the purpose of the silver level folder is to hold clean data. And I'll show you what we're doing with this in the notebook itself while this is executing. By the time I show all this off, then it should be done. So let's get in this actual notebook itself and show you what's going on with it. So in the notebook, you can see that I'm pulling in the data from that 2000, from the bronze level. Now, when the data is loaded in, there's several years worth of New York City taxi. I think it goes from 2018 to 2020 or 22 or something to that effect. Now I'm only pulling in 1 year of data for this. And this is just, like I said, this is just an example. You could set up processes. In fact, for your pipeline, this would be a great way to set up like conditionals. So if I went back to my pipeline and I could set up like conditionals, once this step is complete, I could do an if then right here. And if a file equals 2019, I can run it through one notebook. If it equals this, I could run it through a separate notebook, so on and so forth until it's all done. All right, but let's go back in here. So I'm loading in specifically the data from the 2019. Now you could see that that first step had already completed in here. So when I go back into the pipeline itself and I refresh this bronze file, there should be several years in here. So I got 2018 to 2023 data. So I'm just worried about, for this demo purpose, the 2019 stuff. All right. So that's what I'm pulling in the notebook here, right? Just pulling in, creating a file path, and then reading in the file path. It is in a Parquet file format, which is nice. And then I'm displaying the results just as a sanity check to see what the column names are and what things I could possibly do with this. Now you can see this airport fee, most of these values are null, and they might all be null. So there's something that I could probably handle right there, is I'm going to get rid of that airport fee. I don't think it's going to apply too much for what I'm going to use it for. So we could drop columns, unnecessary columns that, and keep in mind that when we're thinking about silver level, we still want everybody to be accessing the data. So typically, like dropping columns and selecting certain columns may not be part of this process. We just mostly want to clean the data, meaning we want to get rid of duplicates. We want to get rid of or figure out what to do with null values, or sometimes people put negative values in data sets in order to do this, and we want to get rid of that stuff. I'm taking this a little bit further, and if you remember, we can chain methods together, chain Python methods together. So I'm actually doing that. Starting off with the drop duplicates, which will get rid of any, it'll parse through the data frame and look for any duplicate values, and it'll drop those rows. And then I'm also dropping that airport fee column. Once I drop that and it executes these in order, then I have another one where it's going to identify NA values or null values, and then it's going to drop the rows that still contain any null values from it. Now, again, we may not want to essentially drop null values. This is just an example of what we could do. A lot of times we might want to encode those values with a median value if it's numbers or something else. That's something that needs to be decided on before you put this into place. And again, I'm going to display it as a sanity check, right? So here's that data. You can see that the airport columns is gone, and there might be fewer rows or something like that in there because of the null values that were removed. There's ways like you could do a data frame describe, and it'll give you statistical information about this. I'm taking this a step further, this cleaning process. I'm actually going to, and if you saw the visualization exercise, it's kind of the same thing. I'm going to use a Spark SQL method and do a select. So I'm filtering out certain columns out of this, and I'm creating new ones, right? So I'm creating I'm taking the hours out of this and creating hours of the day, day of the week, and day of the month. These columns are going to get added to the data set. And I'm also applying a filter where they have to meet these, since there's ands in here, it has to meet all of these standards in here in order for this select operation to occur. So it's going to filter all this data out, and then I'm going to write this into my silver folder. Now, again, we may want to wait to do this until we get it into gold standard. It really depends on who it's going to right then. Silver level or silver folder, we want just the clean data that everybody can use, no matter what data team it is. When you go into gold, that's when we want to aggregate, filter, and enhance the data for specific purposes like machine learning, like warehousing, so on and so forth, so that those teams have an easier job of what they need to. All I need to do at that point is create tables and load them up, right? And that's great. So we're going to load that into our silver folder. We're also going to, at this point, so this is silver. I've taken this notebook a step further. And again, this is something that you could separate into another notebook or another type of task or whatever, or activity that you want to include. It could be a stored procedure for SQL or something like that in our pipeline. But in this case, I'm using Python notebooks. I'm going to aggregate this. So what I'm doing is I'm going to add a column called fare by mile. And what this is going to do is it's going to take the fare amount divided by the trip distance, so we can get like an average fare per trip. So you can see here that it did that. This is called feature engineering, so I can take multiple columns and create new columns out of them. Sometimes I'll see this a lot with exponential values. If it's between 0 and 1, sometimes exponential values for machine learning processes can find significant, correlations in data and new discoveries. And then we're going to call this, we're going to name a table called Fact New York City Taxi Data, because these are transactional information. And then we're going to overwrite any existing tables. You can see that I'm applying this to a Delta format. I'm going to partition it by the payment type. Why? Because there's two types of, because when you go through your data and you look at this, there's going to be 30 days of the month. There's going to be 7 days of the week. There's going to be 24 hours of the day. And then there's going to be all these different other values. When you decide on a partition key, you want to split the data as evenly as possible between the partitions. So based on all of these columns, it seemed to me that the best option, now vendor ID might be another one, depending on how many vendors there are. This would have been a good choice for a partition. But I chose payment type because it looks like there's only 1, 2, or 3 different payment types that they can choose from. So this should write 2 different partitions for the data, which should be enough for what we're doing. Let's go back to our pipeline here. So you can see that the run succeeded. So now I can go back in to my lake house here, and we already determined that our bronze worked because I got my files or my folders here. Now let's look at the silver level. Let me refresh the whole dang thing, and then we'll take a look at this. So now when I go into silver, you can see that now I got my 2019 silver level, right? And you can see that I have my data written into that Parquet file format. And I also have my fact sale that was created from that aggregation that I put in. Not this one, the New York City Taxi. So fact New York City Taxi. Now I have all this in a table, and I can start performing analytics on it right away. So that's the purpose of a medallion architecture or medallion framework, is to set up these levels of standard, because we don't want to get rid of our raw data. We want to hold on to it. Sometimes you even have legal holds and stuff like that where we need to hold on to this data for a certain period of time. And that's what the bronze level's for. Just put it in there. Then we can take this bronze folder, do things like set up lifecycle policies on this particular folder, where after 30 days it'll get sent to a cool tier, and then finally to a cold tier, where it's not going to be used that much. Storage costs decrease at that point when you switch to different life cycles. And then we can just archive it in a vault after, say, 180 days, because we don't think the data is not going to be valid at that point. We're probably not going to use it, but we may have to hold on to that data for a while. But now I don't have to parse through all these different folders and set up these policies within that individually. I can just go to my bronze file and do this. Now that I got my clean data in silver, we would direct everybody to come into silver and then take it for the purposes that they need it. We can even set up our gold processes and send them either directly to the service that it's going to be at, or we could set up a gold folder, separate them by the different departments that are needed, like gold, and then create a subfolder for the gold that is for like machine learning, for warehousing, so on and so forth. That's up to you to decide. And again, we can take this further, make a platinum level, or we could have even a sub-bronze level where it may be JSON data or something that we're going to have to take it an extra step through in order to get it in be able to work with it in a data frame format. So that's a medallion architecture, or the framework, and just setting up a pipeline in order for us to perform those processes.
Great work, detectives. We learned how to design and implement a medallion framework in Fabric, and how to use it for data exploration, reporting, and downstream consumption. We unlocked the clues on how to secure your lakehouse and how to set up CI/CD processes for your medallion architecture. And yes, these medals are props. I never won a medal for athletic performance ever in my life. I wonder if they'll make medals for fabric training. Thanks for joining.